Hello everyone, welcome for this lecture. Today we are going to move to principle of operation of a three-phase induction motor. Okay, till now we have studied construction of a three-phase induction motor, okay, and the types of three-phase induction motor. Okay, today we are going to see the how it is going to operate. Okay, and when we have studied RMF, which is very important topic, okay, which is RMF, rotating magnetic field. As we have studied this, so even though your stator part is stationary, but a field exerted in that is going to rotate. Okay, that concept we have discussed. So with the help of that concept we are going to move to this. Okay, so principle of operation of induction motor. As we know, induction motor works on the principle of electromagnetic induction. Okay, so what is this electromagnetic induction? Any conductor, okay, or any conductor, or you can say it is a magnet or electromagnet. When you say electromagnet, when a conductor is wounded with a coil, if you pass the current through that, then it becomes a electromagnet. Okay, so then electromagnet, see, so whenever a conductor carries a current, okay, any conductor carries a current, so it starts producing magnetic field. This magnetic field linking with a conductor, okay, this magnetic field linking with a conductor, there will be an induced EMF. Okay, there will be an induced EMF, so that is called electromagnetic induction. Okay, so this induction motor also works on the principle of electromagnetic induction. So let's study how this induction motor is going to work, and then how rotor starts rotate. Okay, as we have seen, this is your rotor part, sorry, this is your stator. Okay, as we know, the stator is a stationary. Okay, and this is your rotor. Rotor is a rotating part, but at there is no supply for this, so it is not at all rotating. Okay, where we have given a supply, now we'll give a supply to the stator. Okay, when you give a supply, three-phase supply, AC supply to the stator, as we know the stator is a stationary part which is not moving at all. Okay, but what happens? RMF concept, okay, recall once, right? When the three-phase power supply is given to the stator, so what happens there? So RMF is start going to produce. Okay, RMF is going to produce, right? So this is RMF produced. So as we know, the RMF is rotating. Okay, so RMF is going to rotate, right, with the speed of ns. Okay, synchronous speed. Now you observe, this is your stator and this is your RMF. This is your rotor. On the rotor, what will be there? Rotor conductors will be there. Okay, rotor conductors will be there inside that. Okay, now you observe, see here, see the flux which is produced, okay, RMF, rotating magnetic field, which is produced, is linking with the conductor. Okay, am I right? So this flux is linking with this rotor conductor. As we know, the according to electromagnetic induction, whenever flux is linking with a conductor, there will be an induced EMF, right? So therefore, this is because of this RMF, this flux or rotating magnetic field is linking with the conductor, therefore there will be induced EMF in the rotor. Okay, so there will be induced EMF in the rotor. So what happens due to this is, so rotor forms a closed circuit. Okay, induces EMF, so it circulates current through the rotor. Okay, once EMF induced in this rotor, what happens there? Current starts flowing through that rotor conductors. Okay, as all the rotor conductors, okay, here we have all the conductors which are all start experiencing force. Okay, due to this overall torque experiences a overall rotor experiences a torque. Okay, when there is a torque, then that rotor starts rotating. Okay, so your rotor rotates. Okay, so when the supply is given to the stator, right? RMF is induced. This RMF, okay, when the supply is given to the stator, into your stator, there will be RMF. Okay, so this RMF is linking with the rotor conductors, induces an EMF. Okay, is called as rotor EMF. Okay, once rotor EMF induced in it, so it starts means it starts flowing. Okay, current starts flowing through this rotor. Okay, that is called as rotor current. Okay, as we know, the rotor, see, rotor is in the rotor EMF is produced, and the and in rotor conductor starts, current starts flowing. As we know, the current carrying through the conductor produces its own flux. Therefore, what happens is, on the rotor, again the another flux, okay, another flux is going to produced by the rotor. Okay, this is stator flux and it is the rotor flux. Okay, it is called as rotor flux. Okay, as all the rotors, okay, as all the rotor conductors experiences this force, okay, the overall rotor experiences a torque. Okay, as torque experiences by this rotor, so rotor starts rotating. Okay, now let's see how this rotor rotates, means in which direction this rotor rotates. Okay, as we explained, everything we have written here. So remember RMF, which you have explained. So RMF, rotating magnetic field, will be rotating in the speed of ns is equal to 120 f by p. Here ns is the synchronous speed in rpm. Okay, ns is the synchronous speed, is nothing but your RMF speed also. Okay, ns speed in rpm, and then f is the frequency and p is the number of poles. Okay, and now see, we'll see how this what is the direction of the rotor. Okay, so suppose if you have assumed the direction of your rotor in this direction, then what about the rotor direction? Okay, so this one is given by according to Lenz's law. Whatever EMF induced will be opposing to the cause of it. Okay, so what happens here is, the cause of the rotor current, okay, whatever current flows through this rotor current, okay, rotor current. So what happens there is, the cause of the rotor current is the induced EMF, okay, which is induced because of the relative motion between the rotating magnetic field and the rotor conductors. Okay, so to oppose the relative motion, that is to reduce the relative speed, the rotor experiences a torque in the same direction as that of your rotating magnetic field. Suppose if you have assumed clockwise direction of your RMF, then your rotor also starts rotating in the same direction, that is a clockwise direction. Okay, so what happens here is, the rotor experiences a torque in the same direction as that of RMF, and it tries to catch up the speed of rotating magnetic field. Okay, so let's say, so rotor speed this is the stator speed. Okay, stator means the stator will not be rotating, but it is called as RMF, means rotating magnetic field speed will be there, that is indicated as ns. And then flux produced by this means rotor, and now rotor starts rotating. Okay, rotor starts rotating, so its speed will be mentioned as nr. Okay, ns is the synchronous speed. Okay, and nr is the rotor speed. Okay, so remember, nr will be try to catch up the ns. Okay, suppose ns is the rotating magnetic field speed, it is rotating in some speed in rpm. Okay, say suppose 1500 rpm. Okay, nr will try to, means nr is what, rotor speed. This is the rotor speed. Rotor speed also tries to catch up this 1500 rpm. Okay, but it will not reach. Okay, if it reaches also, we'll discuss about that matter. Okay, whenever it reaches to this nr, means if ns is equal to nr, then rotor will be stand still, will not be moving, because there should be, means because of some reason only rotor is rotating. Why it is rotating? Because the rotor conductor cuts the flux of RMF. Okay, RMF is rotating, that's why your rotor means rotor conductors cut the RMF means rotating magnetic field, so there will be induced EMF. Because of that induced EMF, current starts flowing through that, and because of that current experiences, so your your rotor starts producing a flux by its own, and then because of that it experiences a force. Okay, so once it experiences a force, you get a torque by that, and then the rotor starts rotating. It all because of your induced EMF in it. Suppose if NR will be equal to NR will be equal to NS, then if both are rotating in the same already those two are rotating in the same direction, and if those two are starts rotating in the same speed, then there will no cut of fluxes. Okay, there is no cut of flux. Therefore, if there is no cut of fluxes or field, then there is no EMF. When there is no EMF, then your rotor will not rotate. Okay, so this is why NR will not be equal to NS. Okay, so we'll discuss in detail about this. Okay, this is how the this RMF speed will be denoted as NS. It is also called as synchronous speed, and NR is your rotor speed. Okay, remember the rotor always rotates in the same direction as that of RMF. Okay, so here we have got two speeds. Okay, here we have got two speeds, NS and NR. Remember, NS minus NR can be get as a relative speed between the RMF and the rotor. Okay, this is how your induction motor works. Thank you.